Welcome everyone. Good morning, afternoon, evening, wherever you are, and thank you for attending our session, FledgePower, a multi-protocol translation gateway for power systems. For this presentation today, we have Akli. Please, Akli, introduce yourself.
Hello everyone, my name is Akli Rahmoun. I am a senior project manager and software architect. I work currently for RTE, the French TSO, and I'm also the chairman of the FledgePower TSC within the LF Energy.
Thank you, Akli. I am Daniel Lazaro, senior technical program manager at OSISOFT, now part of Aviva, where I lead the open source program. I'm also a board member of LF Energy and LF Edge. The agenda that we have for you today begins with collaboration between LF Energy and LF Edge and a bit of history on how FlexPower came to be. We will continue describing the mission of the project, followed by the architecture of FlexPower. Akli will introduce some examples of use cases we're targeting with FlexPower and the significant achievements today to target those use cases, followed by ongoing as well as future work. And we will end up with information on how to further explore the project and join the community, followed by some Q&A. Before we dive into the technical details of FlexPower, I would like to talk about collaboration and to emphasize that beyond its technical capabilities, FlexPower is a cross-foundation collaboration between LF Edge and LF Energy that ensures a strong cooperative governance and technical alignment between the two communities. LF Edge is building an open source framework for the edge, while the LF Energy is focused on power systems. Power systems have a large set of challenges at the edge due to their distributed nature. So why not look into edge solutions under the LF Edge community, see if there is anything there that meets the requirements and expand upon it. That way, we can focus on the specifics to power systems, protocols and such, and avoid reinventing the wheel. And at the same time, speed up the development. This collaboration started with FlexPower's high-level requirements. Simply put, the first two are multiple protocols southbound to collect data from field devices. We find this to be a common requirement for Edge due to diversity of vendors and protocols in this space. Multiple protocols southbound to send data to data centers and clouds. This one, on the other hand, is not so common, and we usually find one type of protocol north. The south-northbound terminology used here is borrowed from the OpenFog reference architecture. The first two requirements are supported by design by the LF Edge project called Fledge. From the list of required protocols, some are already available in Fledge. For the ones that are not, the FlexPower community is currently in active development, as Akli will describe, with the goal of contributing them to Fledge. The third requirement is setpoint control. This is not real-time control, but allows machine behaviors to be modified by altering the operating parameters of a machine. This requirement was not available at the time in Fledge and was requested to the Fledge community that had received similar feedback and agreed to implement it. So let's take a brief look at the Edge taxonomy and projects described in the LF Edge white paper. On the vertical axis, we have applications versus infrastructure. On the horizontal axis, we have the edge continuum that is divided into user edge and service provider edge, both of which are further broken down into subcategories. Each one of the projects solves a different set of challenges at the edge. But what is the edge? If you ask 10 different people to define edge, you will likely get 10 different answers. The state of the edge project on top of the right corner of this taxonomy is an attempt to provide common terminology. It maintains, among other things, the open glossary of edge computing that provides a crowdsourced shared vocabulary for the edge. You can find Fledge on the upper left corner position around the area for applications for the constrained smart device user edge. Fledge is a framework for industrial edge focused on critical operations, predictive maintenance, situational awareness, and safety, what makes it a perfect match for the substation automation use cases that Akli will later describe. So what is FlexPower? FlexPower is a multi-protocol translation gateway for power systems based on the industrial IoT LFH project, Fledge. FlexPower aims to solve the problem of multiple protocol translation by providing the industry with a flexible, lightweight, industrial-grade open-source gateway that embeds Fledge from LFH. Additionally, FlexPower provides a toolbox for simulation, data configuration and validation, focused on protocol translation and use cases relevant to power systems. So now let's put the FlexPower in context with the rest of the LF Energy ecosystem. In this architecture diagram, that is a work in progress, we have again on the vertical axis the application versus infrastructure plane combined with a functional architecture approach. In this approach, FlexPower is positioned as a net solution that is a cornerstone for interoperability between different functions such as legacy SCADA, data and services platforms, APIs, IoT devices and platforms, etc. This is possible due to its flexible and extensive architecture. Moreover, there is a great potential for interoperability and integration with several other projects in the LF Energy ecosystem, such as Sonio, OpenLeader, and HiFi, to name a few. And with this, I will pass it on to Akli to provide an overview of FlexPower's architecture. Over to you, Akli.
Thank you, Daniel, for this introduction and explanation. On this slide, I would like to emphasize on the architecture on which we want to build FlexPower. The main component of the project is the FlexPower gateway built upon Fledge. And the development of the plugins will be focusing on power system telecontrol protocols like 61850, IEC 104, ICCP TASE.2, and like already mentioned by Daniel, some protocol plugins are already available with Fledge, like OPC UA. Thanks to the flexible and extensible architecture of Fledge, we can add any protocol plugin that has value for the industry. Additionally, the project aims also to develop companion tools that are necessary for testing and operating the FlexPower gateway in an industrial context. We have PowerConf, the configuration tool, PowerCheck, the configuration data checking tool, PowerLoader, the configuration data loader and supervisor, PowerSim, the tool to simulate a telecontrol network with FlexPower gateways, and PowerViz, the supervision and hypervision tool. And all these tools will be interacting with FlexPower gateway thanks to the Fledge REST API. Let's illustrate now the usage of FlexPower gateway in two use cases. The first one is a monitoring use case where we acquire monitoring data from substation RTU or remote terminal unit using IEC 104 protocol and send them to a control center SCADA using ICCP TASE.2. The incoming messages are formatted using IEC 104 protocol data model. So here we need to convert the IEC 104 messages into TASE.2 messages via a pivot format. For this, we need to apply mapping rules to be able to map attributes from IEC 104 message objects to the pivot format and do the reverse operation to get a TASE.2 indication point object from the pivot format. The great advantage of using a pivot format is that it allows a one-to-n rather than a one-to-one translation. And this makes the process of contributing to a new protocol plugin much more easier by taking advantage of the work that have been already done. From an end user perspective, we can bring great value for real-time or analysis usage. For real-time usage, monitoring data can be formatted to be presented on dashboards to the operator in different visualization on individual or large monitoring screens. We can also generate from the same data visual notification or sound alarms to give the operator the most recent updates on the system state so he can take the most appropriate actions. And the same data can also be stored on data historians or big data databases for long-term analysis or machine learning purposes. In this second use case example, we have now data that flow in both directions, monitoring and control. We still acquire monitoring data, but now from a substation IED or intelligent electronic device in IEC 61850 to send them to a control center SCADA using OPC UA. And we also acquire control commands from control center SCADA in OPC UA and send them to the IED using IEC 61850. So in the same way we did for the monitoring data, control command objects are converted from OPC UA data model to IEC 61850 data model via the pivot format. And from an end user perspective, this opens the capacity for the operator to control substation equipment's behavior using set point values on transformers, for example, but also act directly on substation topology by opening or closing circuit breakers or isolating switches. So at this stage of the project, we are not yet able to implement these use cases on production using FledgePower, but the project's recent significant achievements make us confident that we are on the right track. We are at the very beginning of the project, but we move fast, and we have already some interesting achievements to share with the community. For example, we have made available a first set of plugins, like the IEC 104 North and South plugins, and the 61850 MMS South plugin. And all these developments have been made possible in a very short amount of time with constrained resources, thanks to a collaboration with RTE, Aviva, Dynamic, N7 Consulting, and SwissGrid, the Swiss TSO. And of course, there is more to come. Currently, we have 3 major topics that give us something to focus on. We are designing and working on the implementation of plugins configuration, which is at the heart of the FledgePower gateway. We are also working on a new implementation of OPC UA North and South plugins using S2 OPC library, offering OPC UA authentication and security. And also, we are currently working on the implementation of set point control. Thank you for listening. And with this, I will pass it on to Daniel to provide an overview of FledgePower future work. So over to you, Daniel.
Thank you, Akli. And as future work for FlexPower, we consider to define a roadmap for version 1.0 that can include core enhancements and features, new relevant plugins, documentation, and integration with other projects in the ecosystem. Deploy FlexPower in production in real substations at scale, expand use cases such as predictive maintenance and others, focus on cybersecurity requirements for power systems, and apply machine learning models at the edge. A crucial goal key to the growth of FlexPower project is a healthy, thriving community around it. FlexPower aims to build and grow a community of end users, developers, utilities, and other players to collaborate to solve current and the future challenges of the energy space. Please join us. For more information and details on the FlexPower project and community and how to participate, please visit the link provided in the slide. And with that, I would like to thank you for your attention. Thank you, Akli, and we can now move on to the Q&A. Hi there, can you hear me?
Hi, everyone.
Can you hear me, Akli?
Yes.
Yes, okay. So I think we have three questions right now. I think the first one is, what is the modeling language of the pivot format? It's probably a question for you. Yeah,
I think this is a very good question. Yeah, currently we're working on the modeling language of the pivot format. So as we have said in the presentation, this is really work underway, and we are exploring we have multiple ideas on how we can make this model. The thing is, we want really this model to be independent from the protocol models, data models. So, and this is really the challenge, is being independent from the protocols. So, and without, we have this challenge, and the other challenge is not to build something too much complex, because actually the getaway, the main feature is being to transport messages from one protocol to another and doing a very simple translation without losing the information, which is also another challenge. So yeah, with all this in mind, we have to find the best model that can accommodate all these constraints and do the job. So yeah, to answer this question, we are still working on this topic, which is really a major topic to design FledgePower translation feature.
Thank you, Akli. The next one is, can Fledge nodes be organized in a hierarchy? For example, the north side of one Fledge sending to the south side of a second one using perhaps 61A50. So the answer to this is yes, and usually the mesh hierarchies that can include hierarchical deployments are usually connected via HTTPS, but due to the extensibility of Fledge, there is no limitations in that regard. You could create a northbound plugin that supports 61A50 and exposes that data, and then have a southbound plugin or another node as a client connect to it and interact with it. The next one is what 61A50 library is used. That's one for you, Akli.
Yeah, we're using a library, an open source library, which is from Incented Automation, and this is a GPL v3 library, which is completely compatible with the license of the project, which is Apache v2. So yeah, to answer, so I can put it in the chat. This is the name of the. So maybe I can also answer also the question. Yeah, there's Sander that had added another question regarding the pivot format. What modeling languages are we considering? For the moment, as I said, there is really the design is underway. So one framework which seems to be very relevant to what we're trying to do is OPC UA. Because actually OPC UA offers really a meta model that can be relevant in our use case. But yeah, we're really at the early stage of the design, and we have to go further and see if this ID can be implemented. I don't know if it answers the question, but yeah, I hope so.
There's another question. How does Fledge relate to the LF Energy projects, GXF, Operator Fabric, REAPS, and Sonio? So if you attended the Sonio presentation previously, we're currently working with the Sonio team to see where the synergies are. We believe that there is a great opportunity to incorporate and interoperate Sonio and Fledge. Fledge offers a set of protocols that are sought after by the Sonio project. REAPS also overlaps with Fledge in the sense that they have a data collection component. They don't follow a microservices paradigm per se, and we've been in conversations with them previously. And I think Operator Fabric and GXF, maybe Akli, we're still looking into possible interactions. I don't know if you have anything to say about those two. You're probably more familiar with them than I am.
I can say a word about GXF. And maybe also with Sonio, because actually I've attended to the Sonio presentation where they are talking about incorporating Fledge in their architecture. And also GXF has a communication layer. So maybe we in the future we'll be working with these two projects and see how we can be a part of the architecture and how we can interact with this project. The other two, Operator Fabric and REAPS, I'm less familiar with these two projects, so I don't. I can say much about these two projects.
Yeah, this is kind of early on work, and we're still looking for collaboration opportunities and the interaction points with other projects. So this is ongoing. The next question I see is, can you handle cases where one message in protocol A maps to a sequence of messages in protocol B or vice versa, like the SIS250?
Very interesting question. I haven't thought about it. Protocol maps to a sequence of messages. I don't understand the question, so I don't want to give a wrong answer. But yeah, basically what we really want to do actually is something at this stage, at the very early stage of the project, is really taking a message, and not a sequence of messages, but really unit messages that comes from the end devices or the control centers, and map them to they will be incoming in an input protocol, and we want them to map them to an output protocol using a pivot format. So this is basically what we want to do in this very early stage of the development of the project. Maybe in the future we can go and think of implementing things around sequence of messages.
But I would say that in general, the answer to this question is yes, since the north and southbound plugins are split and decoupled by the storage layer in between. So messages incoming from a southbound plugin can be then, translated into anything by the southbound plugin. So you could chop those messages into one or more. I mean, you have full control. You also have filtering capabilities in Fledge to allow you to do these kind of things in mode of a configuration exercise rather than programming your own plugin. The part where you ask like the control model in SIS250, since the set point control feature is kind of in its initial stages, I really don't know how to answer that question. Potentially yes, but because it's not final and this is work in progress, I don't want to say yes or no. I think it's possible to do because Fledge is configurable and extensible. So it is possible if you want to do this kind of thing. The next question is, do you have a plan to have SIS250 server? And the answer, I guess, is not in the scope of the current work. But again, it should be possible for somebody that wants to implement this feature to do it in Fledge.
Yeah, absolutely. It will be made possible to implement a 61850 server in the future, definitely.
The next one is, does FlexPower already have any code artifacts on its own? If so, where can we find them?
Not yet, and we are currently also working on this. But at this stage of the project, we don't have any code artifacts.
Yeah, the current contributions have been made directly to Fledge. The plan is to contribute some simulation tools around the protocols that are being developed right now to the FlexPower repository, but I believe they are not available yet, correct?
Not yet. Not yet. Mm-hmm. So yeah, I take also this question to answer. Yeah, maybe to give an answer about how we collaborate with Fledge. So everything that is which is related to the plugins, the protocol plugins, will be directly contributed to the Fledge. So if you want to find the code of any plugin, protocol plugin, it will be on the Fledge GitHub repo, and everything which is related more to the implementation regarding the power system protocols translation and the companion tools will be found on the FlexPower GitHub repo. So this is how we split up and the two contributions.
There's another one. Could you elaborate on the security ambitions on the roadmap, TLS, automated key management? Thanks. So the plan is to basically understand what the requirements for the power sector are in order to basically implement those requirements on FlexPower. Right now, we're working with RTE in Europe, and so we're probably going to focus on the requirements for TSOs in Europe. That's as far as I can go answering this question. And once we expand to other regions of the world, we will have to look into the requirements in those regions. And I think there is another question in the chat. How would you like others to cooperate with you? So I provided a link in the presentation, and you have both our emails as well in the presentation. So one way to go, follow the link for FlexPower, and you will find links to the wiki. And in the wiki, you will find our TSC calls. Please join us on those calls, ask questions, and we can discuss possible opportunities. You're also welcome to contact us directly, and we'll set up a call or whatever is needed in order to understand, what your goals are and see if we can align our efforts. And I don't see any further questions. Okay, well, thanks everyone for attending, and thank you for your time. And please reach to us with any further questions you may have. Thank you so much.
Thank you, everyone.
All right, bye-bye.
Have a nice day. Bye-bye.